morning. This is a problem that we actually did in class on Friday, November 20th, but it's kind of an experiment. For those of you that weren't here in class, this would be a good option for you to use to try to figure out how to do these optimization problems. So one of the first things we need to do is just look at the problem, read through it, and decide what it is we're asked to do. I want you to always focus on the part of the problem that says optimize, find a maximum, find the largest, find the smallest, any sort of item in the problem that tells you you're looking for the maximum or the minimum, which is going to indicate to us that we're going to need an equation and take the derivative of that equation. So in this problem we see we need the maximum product of two numbers, and those two numbers, we can name them with some variables. In class we called them x and y. Those are both positive integers whose sum adds to 20. So I have x plus y equals 20 as a given statement. That's going to be used to substitute. That is not the maximizing problem, that's the substitution problem. So a product can be called, we're going to call it an equation, a function x times y, and that's going to be the function that I take a derivative of. But we want to have our derivative only in terms of one variable. So prior to taking a derivative, it would be really good for us to eliminate the y variable. And so we're going to use this substitution equation to eliminate y. So I can call, instead of x plus y equals 20, I can call y 20 minus x. That way I can put my function, the product function, in terms of just x prior to taking the derivative. Also good if we can simplify that function before we take its derivative. In this case, a quadratic is going to be easier than a product. So our derivative is 20 minus 2x. We know we need to, when we're optimizing, maximizing, or minimizing, we need to set our derivative equal to 0 and solve to find the critical values. And so in this case, the critical values are found at x equal to 10. It's also good to note what the domain of x is, because if we're going to test the critical values, one of our main ways to test the critical values was with the number line, a first derivative test. And we should know not just the critical value, but we should also know some endpoints on logical numbers for that value. So in this case, because we're looking at two numbers, x has to be, and I'm going to go back to the beginning here, x has to be between 0 and 20, because it would add up with a second number to total to 20. So I am going to put that on this number line, knowing that if I'm in that domain, I don't have to worry about critical values outside of that domain. So with the first derivative test, let's test a number just below 10. So for instance, 4 or 7 or something. And the derivative at 7, going back to our derivative function, if we plug in a 7, it looks like we get a 20 minus 14, a positive derivative. And then a point above 10, like 11, plugging that back into the derivative, we get 20 minus 22, or a negative value. Remember that this indicates that the function itself is going from increasing to decreasing, so we have a maximum. And that is what we wanted to do. We wanted to maximize the product. So at x equal to 10, the product is maximized. In addition to that, we should look back at the problem and really answer the problem in a whole way. And so we could add on to that and say that the values of x equal to 10 and y equal to 10, which I got from that substitution equation, gives me two integers, and the product, not prox, the product is maximized at 100. Or that doesn't quite look so good. How about the product of 100 is maximized? Maybe even the product of 100 is a maximum. The real answer down here, you know, you have to think about how you want to phrase that answer to put the question back into context. Okay, so we're going to repeat this with our second problem. Same idea, same process. And I am referring back to that procedure that's at the top of your page there, the top of the worksheet that has all these problems. So we'll start another problem in just a minute.